Okay, here we're going to calculate the volume of a solid of revolution using a different method, this time using a method called cylindrical shells. So in this example, we're going to look at the area under y equal f of x between a and b, okay, this area over here, and revolve it. This time we're going to revolve around the y-axis. And we're going to take one rectangle, one slice of this area, and think about what the resulting volume would look like if we revolved just this red rectangle about the y-axis. And here we have a picture of it on the right. Okay, so we would get some sort of cylinder. It's empty in the middle because we're just revolving this little rectangle about the y-axis. So we would be, it's called a cylindrical shell because it's empty in the middle. Okay. All right. Now, what's the height of this shell? Well, that is the same as this height over here. That would be f of x if this is the point x down here. So this is f of x for the height. And what's the radius of this shell? Well, the radius, when this is rotated about the y-axis, it goes along a circle like this. The radius is from here to here. From here to here. Okay, here's 0. Okay, 0 is right here. This distance is x. From here to here, that's x. If this is point x on the x-axis, this is x. All right, so the radius of the bottom of this cylinder is x. The height of the cylinder is f of x. Now we want to calculate the volume of the cylindrical shell, and the way we do that is picture cutting the shell along the red rectangle. So we're cutting it there and we're spreading it out flat. And here's what we have here. After we spread it out flat, we have this picture. This is our dx, dx on the bottom, and this is our little rectangle. Here is the side of this solid, sort of thin, solid rectangle. Okay, now this circumference 2 pi x got spread out, got opened up. So the bottom of this rectangle is, of this solid rectangle, has length 2 pi x. The height is f of x. The thickness is dx. So this little volume we're going to call, the volume of this cylindrical shell, we're going to call delta V. And it's equal to the product of the three dimensions. That would be 2 pi x times f of x times dx. Oh, there. Okay, so let me write that. 2 pi x f of x dx. That's delta V. So the volume is equal to, let me put the 2 pi on the outside, and we have the integral summing up these v's over here. We have the integral from a to b, x f of x dx. So that's our formula for the volume of a solid of revolution using the method of cylindrical shells.